Hello everyone, welcome back to my channel. Today let's go over another Leetcode medium question that I just solved on my own. So I'm really proud of this because again I was able to come up with my own solution to this question. So I will say that this question was probably one of the most tedious questions I've ever solved. I was stuck here for weeks and weeks and weeks just hitting edge cases after time limit exceeded. But I finally managed to do it today at like 3:30 a.m. by myself without any assistance. So it's unbelievable, but I did it. So let's go over it and let me show you how I did it. The idea is pretty simple. Basically, you just want to divide the array into as many parts as you can where the subarrays are contiguous and all three sum to the same thing. Or at least the left half is less than or equal to the mid half, which is also less than or equal to the right half. So let's go over the brute force way of doing it, which is just to divide from I plus 1 length of nums, and we can just say, let's make a prefix array so that we have all the prefix sums, and then we can just say current is P of I, and at any point if the left half is less than or equal to P of j minus current, which is going to be the middle half sum, because for example the prefix sum of this minus the prefix sum of this gives you the prefix sum of this, and then which is also less than or equal to tot minus pj, and the total is just going to be the prefix sum of the whole thing. So the right half is exactly this. In that case it satisfies everything, so we can just increment our answer, and at the end we will just return the answer, right? So this is n squared. It works, and you don't want to forget the mod here. So mod is 10 to the power of 9 plus 7. Okay, so time limit exceeded, and this is where I was stuck for a long time. But what I finally managed to figure out was that what you want to do is, so we want to have two different halves. So what that means is if you make some observations and you really play around with the test cases, you'll notice that what we have to do is say BL is we have to bisect left inside of P. So let's actually make now equals to P dot copy. So this is the prefix sum. So basically for this would be 1, 2, 3. This is the original input. So we want to obviously delete 1 because we're iterating. We want to get rid of this n squared, right? We were iterating from the right to the end. So basically delete now of 0. And so what we want to do is now we have, so now is what we want. And we're going to be binary searching here to say, okay, is current anything? We're going to try to find a value in this half that satisfies as pj. So if you do a little bit of math inequality here, you'll figure out that is equal to total minus current divided by 2. And first what we have to do is we have to do bisect left on now, and we have to do current times 2. So basically that means that anything has to be at least 2 times what this is, because we have 2 different blocks here. And again, I figured that out just by trial and erroring my way through the test cases. So now that you know that, what we want to do is create a bisect left to the end, and now we can do our binary search on this. So now we just have to, so now that we have this, we want to say less than or equal to right. Mid is left plus right divided by 2. If cur, again the same inequality, is less than nn of mid minus, so nn mid minus current, which is less than or equal to total minus nn mid, then what we want to do is instead of counting 1 by 1, we want to say, okay, up to which point in the right is this still equal? Because the prefix sum, these are all positives, is never going to shrink. So if we get to a point and it's not it, we know everything to the right is not it. So we can just take everything to the left and then right minus left, which is just what we're going to say is right is that point. So at this, we're going to say right is max of right and mid plus 1, because we're saying that, okay, we we included this current element here. So 1, 2, 3, although the index is 2, we want 3, so that's plus 1. And then we obviously want to do that. And left and right. And then at the end, we can just say answer plus equals to right, right, which is basically just because it starts at 0, and we're looking at this new chopped off array. So let's run this. Submit it. And I got stuck here again because this is way too slow. It's reconstructing another list. So how do we do a binary search on a sliced up list? So that is going to be the challenging part. So just so you can see what I'm doing, actually, let's print current and now and tote. So we want to satisfy this inequality, right? And it gets pretty nasty. For example, here, especially, what inequality? So 7 minus 3. 7 has to be bigger than or equal to. So 7 minus 3 has to be bigger than or equal to 3. That's why we do 3 times 2, because 5, even though 5 minus 3 is less than or equal to 12 minus 5, 5 minus 3 is not bigger than or equal to. So 5 minus 3 is 2. 2 is not bigger than or equal to 3. That's why we have to do 3 times 2. So this is the only section that's really valid. That's what this is doing here. And then then we can do the binary search, because 7 minus 3 is 4. This is at least, so 7 minus 3 is 4 is at least bigger than, 4 is at least bigger than or equal to 3. So 3 times 2 would be 6. So that's what we want. Hopefully that makes sense. So now that we got this, how do we avoid reconstructing this list? So how about we just run a binary search on BL? And I'm not going to lie, it took me quite a while to figure this out through a lot of trial and error, but I did it on my own. So BL, and so we still want to figure out where this lies, but instead, because we have a BL, we want to say the index of NN, which is mid minus BL plus 1. So length of now, so we don't have that chopped up list now. So it's now mid, and again, there's an edge case there where basically some really, really big numbers. So what we want to do is say right equals to mid. Let's use this, because for some reason, okay, so mid minus BL plus 1. Is it? Nope. So mid minus BL plus 1. And so plus right. So right can be float of negative infinity, because if right is not changed from the beginning, then we can add it. So hopefully, nope. Okay. So we're bisecting left inside of now that's already been chopped off. So is it mid minus BL, or? Because let's say that we have our binary search on this chopped off list, so then we have to add BL. So it's plus BL, sorry, minus 1, right? Nope. Plus 1. Because we're still to the index to the right. But why is this not? Oh, Lord. Okay. So current times 2. Now of mid minus current. Minus BL plus BL. minus 1. Yeah, this one was a pain in the ass. So mid plus BL. Because we're binary searching from this onwards. So if we have a valid one, we have to say minus BL, right? Plus 1. That's what I think it should be. Okay. Oh, I forgot the mod. That's what it was. Okay. So wasn't this the mistake? I knew that was right because I spent a lot of time on that. Okay, cool. Yep. So there you go. Passes all test cases. Again, really, really happy that I was able to struggle a lot through this question, but come up with my very own solution at the end without any assistance. So really proud of that for such a low acceptance rate question. It wasn't easy, but this is where the real learning happens, is when you really struggle through a question and finally solve it. So it's not when you just look at a solution and 5 minutes and then move on, right? So the real struggle is when the learning happens. Just want everyone to try to remember that. So that's it for this video. Thank you for watching and stay tuned for more.